This video is about DC power. It corresponds to section 4.6 of the Applied Analog Electronics textbook. If we have charge moving through a circuit, so we have a component here and we have charge moving in that direction, and we have a voltage drop VAB. What happens as we move charge? Well, the voltage is dropping, so we're going to be releasing energy as the charge moves. The definition of voltage was that we will have VAB joules of energy released per coulomb of charge. That's basically just the definition of what a volt is. How much charge are we moving? Well, I is coulombs per second. That's what an amp is, 1 coulomb per second. So if we multiply the current times the voltage, we're going to get joules per second. So that's power. And joules per second is usually written as watts. So take the current in amps, the voltage in volts, multiply them together, you get the power in watts. This formula works for direct current, so when we have a constant voltage. It also works for instantaneous power. That is to say, if the current is time varying and the voltage is time varying, this will give you the time varying power. Often we want something other than time varying power. We want some sort of average power measurement. We'll delay talking about that until we've talked more about time varying signals. But this basic formula works for both DC, where there's no change with time, and for instantaneous power. And we'll be using it a moderate amount in this course.